Hey guys, how's it going? So here we have some notes, basically to answer the question of solving questions about probability distribution on a normally distributed curve graph, and we're finding the area or z-score. So this is pretty much how you go about finding the z-score. There's a sample question here over on the left. Pretty much this question is just saying the reading grades of the English class are normally distributed with a mean of 75 and the standard deviation of 4.1. And so pretty much the mean is represented by this symbol mu, and the standard deviation is represented by sigma. And a question you might have is something like, calculate the z-scores for each of the following grades. And so here are the grades. You have a grade of 56, a grade of 93, a grade of 75. Somebody scores 100, they get them all right. A grade of 85. So some notes I have here. The z-score, what you're finding when somebody asks you to find the z-score is you're basically getting the amount of standard deviations away from the mean. So that's what they mean, what they're talking about when they're asking you for the z-score, is you're finding the amount of standard deviations away from the mean. And so I drew out this curve here, which is representing what's given in the problem. So you always want to start with what's given. And what is given here is you're given a mean equal to 75. So your mean is 75, and on a normally distributed curve, your mean is going to go right down the middle. So you have mean mu equals 75, and then you have your standard deviation, which is 4.1. So the standard deviation is the distance away from the mean. So deviation, it's pretty much like the change, or like the distance away from your mean that you have here. And so they're asking, well, they're not really asking you, but it's kind of good to know the standard deviation away from the mean. So if you have one standard deviation in the positive direction away from the mean, that's going to give you 79.1 from 75. And then if you have one standard deviation away from the mean, you're going to have 70.9. And so basically all you do to get one standard deviation away from the mean, because this is one standard deviation away from the mean on a normally distributed curve. So pretty much you would just say 75 plus 4.1 or 75 minus 4.1. Those are the numbers that are given to you already. So nothing special has been done at all at this point. It's already just drawn out. Here it is drawn out. These are all the given pieces of information that you have, and you're also given these scores and parts of the question. Maybe you have 5 parts of the question, part A, B, C, D, and E. You're trying to find 5 answers, basically 5 answers which would be represented in z-scores. And so pretty much you're given everything you need, and all you really need to do at this point is simply calculate your z-scores, really. And so here's an example of part A. How you would solve part A is you would use, well, I guess I skipped one of the notes, but pretty much what we're doing is we're calculating how far is the English grade from the mean. That's all you're really doing. That's what this question is asking you. How far is this English grade here? How far is 56 from the mean? Right? How far is 56 from 75? So that's pretty much how you would solve these questions. You have your formula for the z-score. You have x minus mu divided by sigma. All that really means is you're taking what was given to you. X is going to be this here. X is going to be, for part A, X is going to be 56. So X is 56. So you'd write 56 minus, you're subtracting the mean, this mean here, 75, then you're dividing by 4.1. So 56 minus 75 divided by 4.1. And that's going to give you negative 19 divided by 4.1, which is approximately 4.63. So that would be your answer for part A. Basically, it just says that a score of 56 is 4.63 for your z-score. So this 4.63 is the z-score for a grade of 56 in the English class. So that's all that really means. So you can pretty much solve all these questions similarly. So I'm just going to write your answers over here. So we're going to say z-score is equal to, it's approximately 4.63 we're estimating here. So for this one, the way that you would solve this next question is you would just say 93, right? 93 minus 75, and then that quantity is going to be, again, divided by 4.1, right? And you can pretty much, solve these on your own, but let me just do them one by one. So we have 93 minus 75, it gives you 18, right? And then you're going to divide by 4.1. So you have 4.39, about 4.39 here. The next part of the question, you would have 75. Let's change that number. Let's change it to let's change it to 80. Alright, just to not confuse you. So we'll have 80 minus 75, and then we're going to divide that quantity by 4.1. So you're going to have 80 minus 75, and then divide by 4.1. You get 1.21, or 1.22 actually, about 1.22. And then for this one, for D, 100 minus 75 divided by 4.1. I forgot divided. So that's going to be equal to some of these you can probably do in your head, but whatever. So you have about 6.10. That's about 6.10. And then for this last part of the question, you have 85 minus 75. And then you're going to divide that quantity by 4.1. So 85 minus 75 is going to give you 10 divided by 4.1 is going to give you 2.44 approximately. 2.44. So these are your answers, right? And pretty much what this is saying here is, that these answers are your z-scores for a grade of whatever the grade is. So this 4.39 is your z-score for 93, for a grade of 93. This z-score of 2.44 is your z-score. Sorry, is your z-score for a grade of 85 in the English class. And then I guess the last step you can do is you can always check your work. You pretty much check your work by asking yourself, where does your answer fall on the histogram? And it should be the z-score amount of standard deviations from the mean. So remember that our standard deviation from the mean is 4.1, a distance of 4.1. So it's either 4.1 in this positive direction, or it's going to be 4.1 in this negative direction, right? And your score should fall however many standard deviations away from the mean, pretty much. So an example of that would be saying, let's just write some things in here. So we have the number 56 here. Let's just say that 56 is about right here, right? According to the mean, the score of 56 is to the left of the mean. It's less than the mean. You have these other numbers, right? You have a grade of 80. You have a grade of 80 is for part C. You have a grade of 85. That's for part E. And you have a grade of 93 for B. Sorry, I'm just trying to go in order. Sorry, I know it's I'm trying to go in numerical order, so I'm jumping around. And then for part D, you have a score of 100. This should all fit on the, underneath the curve actually, but because, this pen on this software writes kind of fat, so the numbers are kind of stretched over. So basically, you have your z-scores over here. You have 4.63 here. So your 4.63 here is, we'll put it right here, 4.63. And then for 80, we're going to have 1.22. For 85, you're going to have 2.44. You probably never need to do this, but it's just a bit of an explanation. For a score of 93, you have 4.39. And then for a score of 100, you have 6.10. or 6.1. And pretty much the reason why I wrote these here is just to show that these numbers are representing the standard deviations above or below the mean. So this score of 56 means that you have a standard deviation of 4.63 below the mean. A score of 80 means that you have a standard deviation of 1.22 above the mean. A score of 85 means that you have a standard deviation of 2.44 above the mean. A score of 93 means that you have a standard deviation of 4.39 above the mean. And a score of 100 means that you have a standard deviation of 6.10 above the mean. These are approximations, and I guess also you can kind of take into consideration what you already see here. You pretty much already see that you have this here. It's saying that one standard deviation above the mean is 4.1, right? So another standard deviation above the mean would be adding another 4.1 to your, you would add another 4.1 to your, so you have 4.1 plus 79.1. That gives you 83.2. Actually, let me just redraw that. So it would be about here, right? It would be between these two guys somewhere. So 83.2 would be right there. So you have this second standard deviation is 83.2, right? And that would be, let's see, you added another 4.1, right? And so you can pretty much see how that works. It's saying that, you know, if this is one standard deviation, right? This is one standard deviation here. And then this is the second standard deviation here, right? You can pretty much see that your score above this mean of 75, if you're, it's saying that you're not quite 2 standard deviations above the mean, right? So everything that's pretty much between 75 and 79.1, everything between 75 and 79.1 is going to be 1 standard deviation, right? That's going to give you 1 standard deviation. That's 1 standard deviation. Your second standard deviation, the cutoff pretty much, is going to be between 79.1 and between 79.1 and here you have this 83.2, right? So you see that your score of 80 is not quite it's not quite 83.2, right? 83.2 would be 2 standard deviations above the mean. That's why your score of 80 is 1.72 standard deviations above the mean. You're not quite 2 standard deviations above the mean, but you're more than 1 standard deviation above the mean, which is 70.9. So that's pretty much how you could check your work. You can pretty much just say, okay, like, what's my score? You know, you can write out all the scores that you're given, and then, you know, compare them to the mean. So the mean that was given to you was 75 in this question, and then the scores that were given to you were 56, 80, 85, 93, and 100. They weren't in that order in the problem set. Maybe they likely won't put them in order in the problem set, but you know, you'll write them out in order, and then pretty much the scores, the z-scores that you get based on the English grades, you're going to kind of line them up with your, you're going to line them up with the score that, well, the grade, I'll call it a grade instead. You're going to line it up with the grade, and then pretty much you can test your answers by looking at how many standard deviations above the mean you came out with. So, For example, if you're already given that 4.1 is the standard deviation from the mean of 75, you're already given that. And so every time you're just adding 4.1, adding 4.1, a third standard deviation would be another 4.1 away from this second standard deviation, and so on in this direction. And in your negative direction, you're going down. So in your negative direction, you're going 4.1 away from 75, so less than 4.1. So you're subtracting 4.1 from 75, and then the second standard deviation would be that you're subtracting 4.1 from you would subtract 4.1 from 70.9 to get your second standard deviation. And so you would check your work that way. Like, this isn't very accurate of a graph just looking at it, but it's kind of a rough representation of your spread of answers that you got, and you can kind of just compare what you got to what was given and kind of make sure that everything's kind of on track, because it's pretty easy to make mistakes with all the little arithmetic parts of the question. So that's pretty much how I look at it. I mean, it's hard for some people, but I hope that helps someone. I hope it's kind of an easy way of looking at z-scores and probability distribution on a normal curve. So I guess if you guys have other questions, you can go ahead and ask. But so far, this is the first video I've come up with based on questions that I've seen. So yeah, hope you guys enjoyed, and good luck.